Hello, I hope everyone is well. The purpose of this video is to walk through a sample stoichiometry problem when the mass of a reactant is given and the mass of the product is what we're trying to find. So here's the problem we're going to take a look at. This is 23A. This is from Introductory Chemistry, a Foundation by Zumdahl and DeCoste. And we're given that we have 1.55 grams of CS2 and we want to find the mass of each product. So we want to figure out how much CO2 and SO2 that we're going to make. So the first step in this problem is to balance the equation. The way that we do that is with a coefficient of 3 here. That gives us 6 oxygen atoms total on the reactant side of the equation. And we need a coefficient of 2 here because we want a grand total of 6 oxygen atoms. We've got 4 from this unit if I'm doubling the sulfur dioxide molecule. Implied coefficient of 1 here means along with those 4 oxygen, we've got 2 more oxygen for a total of 6. And then our totals for carbon is just, again, implied coefficient of 1 here. 1 carbon on each side. And then 2 sulfur atoms on each side of the equation because, again, we've doubled the sulfur dioxide molecule. So that's an important first step. So we were given 1.55 grams of CS2. I've got this set up here in a BCA chart. So we've got the amounts before the reaction happens, the change that occurs in the reaction, and then the after amount that we have after the reaction has occurred. So once we have kind of set that up, what we need to do is, our first thing we need to do is convert from grams to moles. So I've done that here, but I want to explain how that is done. So if we want to convert anything from grams to mole, we need to determine its molar mass. So if we go to the periodic table for the elements involved here, the number beneath the chemical symbol here is the relative mass, which also tells us the grams in 1 mole of that material. So if I had a 1 mole of carbon atoms, it would have a mass of 12.01 grams. When I have something like CS2, I need to add up those individual molar masses to get the molar mass of the compound. So let me show you what that looks like. I'll move my sheet down a little bit. I've taken a grand total of the molar mass of a carbon atom plus 2 sulfur atoms to figure out that the molar mass is 76.15 grams. Now, coming back up, how did I get that number? How did I get 76.15? Well, I took 12.01, there's one of those, and I added it to 2 times 32.07 because the molecule CS2 has 2 sulfur atoms. So if this is the molar mass for a single sulfur atom, I need to double that to get the molar mass of the compound. So basically 12.01 plus 32.07 times 2 gives us 76.15. I've set this up with a conversion factor showing cancellation of units, dimensional analysis. Again, my given value is 1.55 grams of CS2. So the grams per mole, if I'm multiplying, the way I want to set that up is that the gram amount is on the bottom, the 1 mole amount is on the top. So that's how I arrived at that 0.0204 moles of CS2. Just to kind of look at the other molar masses, for oxygen, the molar mass is 32 grams per mole, and I'll explain why it's switched here in a moment. And then for CO2, adding up 1 carbon and 2 oxygen molar masses, we get 44.01. And then likewise for SO2, adding up 1 sulfur and 2 oxygen molar masses to get 64.07. So back to the BCA chart. Once I have determined that this mass of CS2 represents 0.0204 moles, then I can use the coefficients to understand how much of these other things are going to react and be produced. So the question didn't really ask it, but just for completeness, because there's a 1-to-3 ratio here, if I react this many moles, 0.0204 moles of CS2, 3 times as many moles of O2 are going to be needed to react. So this is just 3 times 0.0204. On the before line, we don't have any products, so those both start with 0 moles. So the change that occurs if this reacts in an ideal way is you're going to lose all of the moles of CS2. You're going to lose all the moles of O2. 3 times as many moles will react out of O2 compared to CS2. And then over here, what we're going to create then, what we're going to make is, again, dictated by the coefficient. So there's a 1-to-1 ratio of CS2 reacted compared to CO2 made. So if it's 0.204 moles that's reacting of CS2, I'm going to make that exact number of moles of CO2. Again, that's because they have the same coefficient. It's a 1-to-1 ratio. If I look at SO2, that's a 1-to-2 ratio. So I'm actually going to make twice as many moles of SO2 as CS2. So this 0.0408 is just reflective of twice as much of this will be made as this is reacted. Again, moles is how we count up atoms, count up molecules. So what we're left with after the reaction occurs is no reactant left, this many moles of CO2, and this many moles of SO2. So to really kind of complete the analysis, what they're asking is, well, how many grams would this be? How many grams would this be? So let me move down to that calculation. So from the BCA chart, I figured out that we're going to make 0.0204 moles of CO2. The molar mass is 44.01 grams in 1 mole. So again, multiplying in this case, I'm trying to move from moles to grams. So I've flipped the sense of the conversion factor because I want moles to cancel. I want to end up in grams. And that's the gram value equivalent to this many moles of CO2. In a similar way, I'm calculating how many grams of SO2 I made from the grams per mole, the molar mass conversion factor, to get to that. So you may have noticed in the key a little side calculation. If I add these up, this would be the total mass of the products. Without rounding, we have 3.508. And on a lot of these, I like to just choose a decimal place to round all my work to. So, and this would be reflective of a typical balance in the lab that maybe goes to 2 decimal places. We would expect to make a total of 3.51 grams of product. Why does that matter? Well, we can check to see, is that how much reactant we started with? Mass is conserved in a chemical reaction, so the total mass produced should equal the total mass reacted. So going back up here in the key, we already knew, because we were given the value, that we started with 1.55 grams of CS2. Again, you wouldn't have to do this, but I determined that, again, 3 times as many moles of O2 would react. So I wanted to say, if that is how it reacted, how many grams of O2 would that be? So again, using the grams per mole, the molar mass for an O2 molecule, to figure out that the mass of O2 that would react would be 1.96 grams of O2. And then what I've done here is just added in the 1.55 grams of the other reactant, the given value, the CS2, to show that that total reactant mass was 3.51 grams. And again, I proved before, kind of showed how the total product mass was also 3.51 grams. So on this type of problem, you know you've done it correctly if you have the exact same mass starting in the reactants as you do in the products. So it's a good check. Now the textbook question was really only asking for these two values. 0.898 grams of CO2 would be produced, 2.61 grams of SO2 would be produced. Hopefully that helps. Again, if you have any questions, you can contact me. And again, I hope everyone is well, and see you soon.